adding graphene into that concrete mix enabled us to radically reduce the amount of concrete that we need for the same strength. Now, if you only need 40% or 50% of the concrete to achieve the same kind of strength, you can do two things. You can make things much stronger. So if you're in a hurricane situation, you can make your foundations much stronger for the same volume. But you can also reduce the amount of raw materials that we're using. Cement manufacture or cement production is very, very wasteful to the environment.
Hey everyone, welcome to It's a Material World. We're the show that uncovers why material science will change the world. Consider subscribing and hitting the like button down below. It would really help us out. And also, we have a free MSE Company Database categorized by industry sector, location, as well as internship and full-time titles. So if you're interested in that, you can find the link in the description below. And now, let's get on to the episode.
Hey everyone, today's guest is Neill Ricketts, the CEO and founding director of Versarien, an advanced engineering materials business that develops best-in-class graphene powders and inks with the goal of disrupting a wide variety of industry sectors, including construction, textiles, energy, automotive, and aerospace. Neill led Versarien's growth from 2 men in a garage in 2011 to a team of 100 employees in just 4 years. He's had over 20 years of combined experience at engineering firms, manufacturing companies, and of course, starting Versarien. We are so excited to bring him on today to share his wealth of knowledge and insights on the graphene industry. So thank you so much for joining us, Neill.
Thanks very much, guys. I really appreciate the time.
Yeah, awesome. So you told us previously through an email call that you're like a self-proclaimed geek and avid fan of Star Wars, especially as a kid. So how did your fascination with this world of science fiction contribute to your motivation behind, starting your own company?
Well, I think, so my first ever film I went to see was Star Wars, as a young kid. And there was this kind of, we can explore the galaxy and we can do all these things. And I was just kind of like blown away that someone, could think that we could even do that. We were kind of like knocking around in the 70s, in gas guzzling cars, and, everything seemed different at that stage. There's no cell phones or anything like that. And these guys were, communicating, and they were traveling, and my eyes just kind of opened up to the possibilities that actually this was achievable. Now, I know, Star Wars is make-believe, but if you look back on Star Wars or Star Trek, you kind of see how that kind of drove progress, because what engineers and technicians were trying to do was to replicate, what that technology was. So, your cell phones are the telecommunicators, and, we're starting to get robots building buildings, and, this is all starting to come alive. And it's surprising what kind of impact those kind of events can have on people. And I think if you were to ask people like Elon Musk, it would be the same. It's about people opening up your mind to what is possible. And so, my dad was an engineer, and I'm very proud of the fact that he was an engineer. And, I kind of like took my toys apart and I tried to rebuild them. I wasn't as successful at putting them back together as I was taking them apart. But I learned the skills that I needed in order to become an engineer. And I did that in the automotive industry. I did that in the Formula One industry, the oil and gas industry, the aerospace industry. And then I realized that actually I had the ability within me to think about how we could challenge some of these things that we've been doing for an awful long time. So a lot of our materials technology dates back to the Second World War. And now we've got the opportunity to actually bring on board a whole new generation of materials. And that's why I became very excited about graphene and its brothers and sisters. There's up to 2,000 new materials that could be available that could change the way that we do things.
So with being a CEO and, starting your own company, what do you think the balance is there between, having this vision for what could be possible 5 years down the line, 10 years down the line, versus the other side of the coin where it's all about like executing efficiently and making sure you're making consistent progress?
So I think there is a balance to be had, and sometimes I've got that balance wrong. When you're the CEO of a tech company, it's like seeing the world in a different color to everybody else. And you kind of look at things and you think, that's not how we should do it. We should do it in a different way. And everybody's saying, no, we've been doing it that way for 40 years. Let's 3D print a house. And they're like, no, let's use a bricklayer. And you have to be aware that you don't see the world in the same way as everybody else. So you kind of need to encourage and bring those people along for that journey. And Sometimes, I mean, I use Elon Musk quite a lot as an example, but there's lots of other examples. Yeah, what you think he says is completely crazy. What you see in the films, go back to that Star Wars thing, they look crazy, but actually we can achieve those things. And so for me, it's about bringing those people. It's about creating the right teams that can actually deliver on that. So, I am a practitioner, I am an engineer, I'm a technologist, but I've got a great team around me as well. So part of my job is creating that vision that gets us from 2022 to 2027. What factories are we going to need? What people are we going to need? What R&D are we going to have needed to have completed? And so I have to kind of temper my view of what the future holds to actually think about how we deliver it. And that's quite a difficult job to do.
So yeah, you've worked in numerous industries, like you said. So what factors played a role in your decision to hedge your bets on graphene and making that the material of choice and the primary focus of Versarien? And then what properties of the graphene made you so bullish on the applications that you could apply it to?
Okay, so I first became kind of interested in graphene in about 2011. So it come out of the University of Manchester. The two professors there had got their Nobel Prize of Physics. We kind of became interested, but we were kind of really, really skeptical. I mean, when people start talking about wonder materials and industrial revolutions, you're kind of like, yeah, okay, I've heard all that before, But, my background was in trying to change. My whole career has been spent trying to change industries. Formula One is a great industry to be involved in, and I know you're currently involved in doing an intern yourself, David. It's about challenging what's gone before. It's about actually, thinking, do we have something here that can actually make a big difference? So 2011, really skeptical. 2012, started to get interested, started to see some of the data, some of the scientific papers were starting to get really interesting. 2014, we have the chance to buy the research, or the company that was involved in the research originally. And that was a small company called 2D Tech in Manchester, and we could make 0.5 gram of graphene a week. And you're never going to be able to create a lot of product using 0.5 gram a week. But the initial promise of that, the initial data, I kind of like stood up and thought, do you know what, this could be really, really special. There's a lot of hard work between 2014 and 2022 to be able to not only to scale up the production of that, but to get graphene to work in other materials. So graphene itself is a great material, but when you start adding it into other materials, you can see exponential performance improvements. So if we put it in concrete, for instance, we can see 30, 40, 50% improvements in mechanical strength, compressive strength. Now, as an engineer, I'm used to chasing, a few tenths of a percent, trying to get that last little bit out of, a racing machine or a plane or whatever. And then suddenly you kind of get a chance to get 30 and 40% improvements. So we started playing with putting graphene into other materials like plastics and elastomers. We suddenly realized that no matter what we put it in, it made a drastic improvement either to its electrical conductivity, its thermal conductivity, or its mechanical strength. We also started to see that it had lots and lots of secondary benefits. So I know, we've been talking about medical, we saw that actually, we can use it as a drug delivery system. We can target tumors using various derivatives of graphene. We can use it to carry drugs. We can improve the mechanical properties of implants. We can actually improve the biocompatibility of things like stents. There's a lot of applications that we've only really just started to touch on. But the initial data was a real leap of faith, by me and my colleagues to say, yes, this is going to work. We can make it work. And that's what we've been doing for the last few years, is proving to everybody that it's not just a clever idea. It's actually deliverable on a practical level.
That's awesome. Okay, so I have questions about that scaling up process and what exactly that took, but I wanted to talk about it maybe in the context of like graphene infused concrete, like you mentioned earlier. So just brief background, cement production is responsible for about 8% of global CO2 emissions. But recently, Versarien found a way to utilize graphene to reduce the amount of cement required to produce concrete, which is, as we know, used everywhere. So can you talk us through how how exactly you're able to enhance concrete with graphene and the results you've seen so far in this implementation.
Yeah, so a lot of the stuff that we're working on has massive benefits for society. One of the things that we're all challenged with is our environment. We've been quite lazy over the last probably 100 years since the Industrial Revolution, and we've kind of taken it for granted that we can do whatever we can or wherever we want, so it doesn't matter whether that's petrol consumption, plastic consumption. We're kind of like wasteful as a society at the moment. I think that's really going to radically change over the next couple of decades. What we've been doing in concrete is we've been adding very, very small quantities of graphene, 0.1% by volume, and that's making a massive difference to the compressive strength. So we're just about to launch a white paper. Everything we tend to do as a company, we get independent research on or independent testing on, and adding graphene into that concrete mix enabled us to radically reduce the amount of concrete that we need for the same strength. Now, if you only need 40% or 50% of the concrete to achieve the same kind of strength, you can do two things. You can make things much stronger. So if you're in a hurricane situation, you can make your foundations much stronger for the same volume. But you can also reduce the amount of raw materials that we're using. Cement manufacture or cement production is very, very wasteful to the environment. But so are textiles, and so are plastics and packaging and so on. Now, as a society, as I said, I think we've been quite lazy. We've been kind of sat back a little bit too much. We don't really see the urgency. We're starting to see that urgency more and more. As climate change starts to make a bigger impact, people are going to become more cautious about what they do. I know that I've changed my behavior. I know that, I'm trying to get my children to change their behavior as well. And so I think technologies like graphene are only going to become more and more important in our challenges as a society.
Yeah, so you talked about cement and how wasteful it is. So as a comparison, when we start to try to focus more on graphene, scale up graphene, how sustainable is that process compared to all these other wasteful processes that we currently use, like you were talking about textiles and cement?
So that's a really, really good question, David, and one that we're challenged with at the moment. So we don't want to create a solution which is worse than what we're currently doing. So we've internally, we kind of think we're ahead of the game. We're trying to work with a lot of different agencies to look at that sustainability question. As it stands at the moment, you can create graphene. You can grow graphene. You can use waste gases in a synthetic way, which is obviously a great use of products which would endanger the environment. But we can also use mined graphene, and if we're going to mine graphene, we need to make sure that the benefits far outweigh what the current situation is. As I said to you before, a very, very small quantity of graphene, 0.1% by volume, can lead to 30 or 40% improvements in the mechanical properties of some of these materials. So in that case, it's a very, very small quantity for a very, very big benefit. Now, sustainability is like all things. I'm a great advocate for electric cars. I drive a Tesla. I think it's sometimes you kind of sit there and wonder why the world's not moving quicker. But actually, charging a Tesla from a coal-fired boiler or a coal-fired power station is not going to improve the environment. However, if we're using far more renewable energy, then actually it's a perfect solution. You're taking what is already generated and turning that into something which is usable without making an impact on the environment. And so I think we need to look at that in terms of graphene as well. So it's all about where the graphene is coming from, how it's you've got to look at the whole thing from beginning to end, from cradle to grave. And that's what we're doing. So we have a head of sustainability. He's asking all of the right questions. We're working a lot with our customers, and a lot of our customers are saying the same thing. What is the solution, and how does the solution compare to what is currently the kind of normal process? And is the benefit big enough? Sometimes it's not about the economy. Sometimes it's not about the cost. Sometimes it's just a really bad current solution, and we need to find an alternative.
So taking a step back to how you initially saw that it was very difficult to scale up production of graphene. So I was just curious about maybe the challenges you faced and generally how you went about eventually addressing those challenges and finding solutions towards that. You don't have to share any proprietary information, but I was just curious because that seems to be a common challenge is, large scale production of nanomaterials.
It is the biggest problem. And I've got to be honest, I think there's better ways of earning money than trying to scale a business. It's an extremely difficult, challenging, stressful, it's very expensive. And it's not until you've actually completed the job that you look back and you think, why did it take so long, and why did it cost so much money to get to this point? So in our journey, we've gone from making, a few grams a week to making, tons of the material. And that's been a constant process of evaluating the process, looking at new techniques, looking at new challenges, trying to solve some of the problems. And unfortunately, when you go from making a few grams to making a few tons, it isn't a straight line. It's very much kind of 2 steps forward, 1 step back. So you solve a problem, you create a problem. You solve 2 problems, you create 2 problems. And so the way that we've been able to do that is the team has been working together for over 30 years doing just this. It's been scaling processes. It's been bringing new technology to the market. And so we kind of fight like brothers and sisters, but actually, we all respect each other. And I think the way that we've been able to generate such great progress is because of that team. The way that team binds together, overcomes those challenges. It's not a 9 to 5 easy thing. And no business that scales is. If you talk to the guys at Apple, you talk to the guys at Dell, you talk to the guys at Amazon, Alibaba, they all have the same problem, which is it looks easy from the outside, but actually the detail inside is really, really tricky. And going from making a few things to making thousands of things, there's always things that you can improve and get better. And people have to be a little bit tolerant.
And I bet like one of those characteristics for a team member is just constantly being curious and asking, if that's the way it's always been done, how can we do it better? So I think that could also just translate as for MSEs everywhere as just a strategy to like better themselves and better the companies they work for as well. So I just wanted to hear your thoughts on how, I guess, what questions can you ask yourself to constantly find those areas for improvement when you're working for a company or in a research position, et cetera?
Yeah, so I think resilience is one of the big characteristics we look at internally. So it isn't going to go right. People live, it's not unicorns and rainbows. It is hard work and it's not easy. And so we look for resilience. We look for those people that are just going to keep on going. Knock them over, they get back up, and they climb back on the horse, and they go again. And so that's one thing. The other thing is we need a lot of enthusiasm. Okay, so when everybody else is, in our case in the UK, going down the pub or going to the bar in the US, then you might not be doing that. You might be waiting for that experiment to finish. But you know what? The thrill and the adrenaline of getting something right is just like the best thing in the world. And so for me, proving those people wrong is a big part of what I do. You go to people and 90% of the population will either not be bothered or won't believe that it's possible. And that 10% are the people that are absolutely driving progress. If you just look at the things, I mean, can you imagine like Steve Jobs not thinking that the iPhone was ever going to be the best thing in the world, or the iPad, or, it's just those kind of people that are driving that. And we've all got a part to play in that. Slightly bigger than that is that I came from an ordinary background. I'm now, chasing my dreams, and everybody has that ability, and part of that is because I was brought up never to consider that, there is anything that's off limits. I have no safety catch. I don't really care if I'm talking to royalty or prime ministers or the guy who's working in our factory. You've got to have that belief that there isn't anything that you can't do. There isn't any challenge out there that's not possible. And not everybody can do that. And not everybody's going to do that. But if we want to explore Mars, or we want to build a colony on the moon, or we want to live under the ocean, it's going to take those people that have those ideas, and also those people that can actually make those things happen. And that's what we do as a group of people. We make those things happen. and it's not easy, but it's really, really rewarding.
Well, yeah, that's great advice in general. But going back to some more technical applications, Versarien also produces electrically conductive graphene inks, appropriately called graphinks, which can be used for energy storage devices. Can you walk us through why this application is particularly interesting for MSEs, but also what makes graphene so adept at working in energy storage devices?
Yeah, so if we look at the three key properties of graphene, the thermal management, the electrical conductivity that comes about from being a single or a thin layer material, and then the mechanical strength. Well, two of those are requirements for energy storage devices. The thing that kills batteries is the thermal load, when we're charging. And, anybody who's got a mobile phone that insists on sleeping at night while it's charging will know that it gets very, very hot. And so graphene can actually help with the thermodynamics of those cells, but it can also help with increased thermodynamics. And graphene itself can be a scaffold on which you can put other things. So we can radically alter the chemistry of things or the physical properties of the graphene sheet by adding other elements. So this is, I think the best analogy was when I was an apprentice. I used to make things to thousandths of an inch. I used to think I was really, really clever. This is like amazing, and then I started working with coatings. I could make things to microns, and I was like, oh, this is amazing. We're thinking about things that are now thinner than the human hair. But with graphene and two-dimensional materials, we're talking about atomic science, we're talking about quantum science, we're talking about the interaction of atomic elements. Now, to me, that is simply staggering. And when you go to the University of Manchester and you see, one of the best microscopes in the world, looking at an atomic structure and looking at the defects in atomic structure, that's really, really exciting. So in energy storage, we need, if we're going to continue at the pace we're at, it's almost a limiting factor now. Better devices that last longer, that are safer. I don't know if you've ever seen a lithium battery go up, but it's probably one of the scariest things you'll ever see. And we sit with our mobile phones in our pockets, and there's a little time bomb waiting to go off. But we need this technology, okay? If we're going to seriously look at off-grid energy storage, if we're going to look at supercapacitors, forming hybrid cells with battery cells, if we're going to look at electric vehicles, we really need to keep pushing those boundaries. And the reality is that we haven't seen very much change in battery technology over the last 20 or 30 years. It needs that step change now. We don't need to do 200 miles in a car. We need to be doing 500 if we're going to, take the next leap into that technology. But it's the same for a lot of other industries. It doesn't matter whether it's mobile communications or it's any of the energy storage things. Graphene can also help in things like PV cells. It can help in the batteries, as we've spoken about, but even the cabling, so if you think about aerospace, when we want to de-ice a plane at the moment, we spray it full of dangerous chemicals to try and get the ice to thaw. Well, we can build in electric systems, electric heaters into the wing structure, into the composite structure, which enables it to de-ice without using those nasty chemicals. And I believe we've got to stop doing some of these things. And the reason that we don't do it is because either the solution is not available currently, or it's just not a high enough priority for us. So we've got to make it a priority.
So from the basics, I was just wondering, what is it about the structure of graphene and maybe its related materials in that family that give it that thermal management properties and maybe the electrical conductivity properties as well?
Okay, so if you imagine that a lot of these, so when we make graphene from graphite, if we're using a kind of top-down process, we start off with millions and millions of sheets stacked on each other. And what every process that's creating graphene is trying to do is to try and chemically or mechanically break those down into the fewest layers that it can. In doing that, there's less room for waste in either the thermal transfer or the electrical transfer of those atoms. And so you get a much more efficient and much more useful, to be honest, transfer of both electrical and thermal conductivity. So if we're going to look at faster computers, quantum computers, then we're going to need to use things like graphene. Now, graphene has its own issues around bandwidth, but it's about that transfer of energy from one end to the other end, which this kind of science just didn't exist 10 years ago. I think it's still got a long way to go in some of these semiconductor applications. We're doing quite a lot of work at the moment with our South Korean operation around printed electronics that are created using chemical vapor deposition. So synthetically creating graphene on a copper catalyst, which we then remove. That leaves you with a single layer of carbon atoms, which are extremely conductive. And that's when the kind of opportunity arises for all of these electrical devices to be much better than what they are currently.
So yeah, after listening to you talk about all these applications, it sounds like there's two main areas of improvement. So it's the actual application. So figuring out how do we get graphene to work the best to its ability in these certain applications. But also it sounds like we have so many applications we're going to need a lot of graphene to actually be able to scale any of these applications to a meaningful size. So could you kind of elaborate on where is the most room for improvement and innovation in the space? Is it the actual applications, or is it getting enough graphene so we can actually make these applications?
I think it's a little bit of a mixture of both. There's lots of market reports out there that show that we need, thousands of tons of material by, the middle of the century. And so for me, it's about focusing on certain applications that we know we can make a big win very, very easily. So these aren't necessarily the most eloquent, so quantum computing is really, really sexy and everybody wants to be involved in quantum computing, but it's really, really hard and it's probably going to take us 50 years. But, we will have lost the momentum if we kind of rely on those, really big electronic challenges. So what we're trying to do is we're looking for the ones that we can change the quickest. So these, in our particular case, what we're focused on is textiles and we're focused on construction, because we know that they're big wins. We know that once we've started those, then we can get the firepower to attack some of the other challenges. We're working with automotive companies and aerospace companies, but they have, quite long lead times on what they're doing. It takes you, 5 years to get a change within automotive, probably 10 years within aerospace. But we're starting to introduce that technology now. So we need to build a kind of roadmap of those things that we can attack relatively quickly and those things that will take longer that we need to start. So there's no doubt in my mind that there's a kind of hockey stick that happens when people start adopting this technology. And that's what we're starting to see now. We're starting to see more adoption. We're starting to see applications which are very similar to each other come on stream.
That's awesome. So you mentioned, like the possibility of colonizing the moon or traveling to Mars. And you told us in a previous email that graphene could potentially make an impact there in space travel. And I remember my dad talking years and years ago about how carbon nanotubes or graphene ribbons could potentially be used for like space elevators. So I just wanted to hear your vision on the role graphene could play in that type of world, like how its tensile strength or other properties can be manipulated for space related applications.
There's no doubt that traveling in space brings its own issues, and we've got to think differently than what we are here. It's the same challenge actually if you're going to try and colonize the seas. We're kind of getting very excited at the moment that actually, the future might be under the ocean, So it's the same challenges, but we've got to think in a completely different way to how we currently think. I mean, there's a big difference even between the US and the UK. You think that they're very, very similar, but when we construct houses, we construct it in a very wasteful way. We construct it using skilled labor to lay blocks in a very slow and skilled way. In the US, obviously, you use a lot of timber frame, and that's quite wasteful in its raw materials. We have to grow the trees for 20 years, and then we have to cut them down, and then we've got to make our houses. And if you're going to go to the moon or you're going to go to Mars, you can't take those skilled people with you necessarily. You can't take, billions of concrete blocks to build. You're going to come up with a different way of being able to do it. And so what we're looking at here is we're actually 3D printing from materials which are readily available at the source. And so you're taking you're taking plant and equipment that's automated, and you're taking very, very small quantities of material that enable you to use the stuff that's available. But those are the kind of challenges that you can overcome. But even in the structure of the rocket, even in the fuels, even in the way that we kind of that everything is actually kind of managed on the spacecraft, the thermodynamics will be quite a challenge. And that can only get worse, that as the more people that start to travel, the bigger the demands become. So filtration and water recycling and all of these things are challenges that graphene has been proven to be effective in. So, there are academic papers that show that you can even filter waste that has been contaminated by nuclear waste back to drinking water. So there are a lot of challenges that these new materials can overcome. And as I say, we've only started playing with 3 or 4 of these types of materials when there's probably 2,000 to go.
Do you see the possibility, you mentioned 3D printing, so it just got the wheels turning in my head, I guess, the possibility of 3D printing like nanomaterials, like graphene or carbon nanotubes, is that possible? Is that feasible?
I think it's possible. I don't think we have the technology currently, and I don't think it would be the most effective way of being able to do it. So creating big sheets of graphene using chemical vapor deposition is quite an efficient way of being able to do it. So it would need to challenge those things. But who knows in the future, it could be. What I do think there is the opportunity for us to create a variety of different materials using graphene as a scaffold. So maybe, you go to your replicator and you get a different type of material that's created by functionalizing a graphene sheet. And, I see that really being a possibility. The same type of material can be used for filtration as it could be for a variety of different applications just by changing its chemical composition. So graphene itself is extremely flexible, and I don't think we've even touched on what the capability is yet. I think that's the really exciting thing for me, is that every day is a learning day. I used to work in an industry which was very traditional, and every day was the same. Every day at Versarien is different. There's always something new. There's always another application. There's always a different material that we can actually, start to play with and use. So I think there's a huge opportunity for anybody who's involved in the scientific field to kind of come on board and see what we can do with these new materials.
Well, in order for the next generation of MSEs to help you create meaningful change, I think it's also important to know the challenges that you're facing trying to scale up this process. From your perspective, what are the main challenges the graphene industry is facing in terms of manufacturing, design, and or adoption into real-world products?
So I think the biggest challenge we face is adoption. Is overcoming overcoming inertia, creating that momentum that makes change. So if you think about electric vehicles in the UK, it's very, very strong. In Scandinavia, it's even stronger, and that's driven by climate change. That's driven by an external influence. There's no doubt that if things continue to get worse on Earth, that the move towards space travel will become an even greater priority. We're seeing a huge amount of development in the last 3 or 4 years compared to the last 40. And so I think regulation, I think macro events, I think changes, economic changes. We're seeing, people questioning, why are we still using gas and oil when it's a commodity which you can find yourself almost being blackmailed over, when there are lots and lots of viable alternatives. So I think that's one thing. I think the other thing that's a big challenge is the priority. We don't necessarily give the priority to making these changes. I think we're quite happy to just continue doing what we've been doing for the last 100 years, when actually, if you think about the last industrial revolution, that challenged everything. It challenged travel. It challenged, the way that we worked. It was a fundamental change to society, and I think that's what we need to a certain extent. We need that change, which forces a lot of people to really look look at what they're doing. I have no doubt that the climate will do that. I have no doubt that where people were mocked for having solar cells or electric vehicles, it'll be the other way around in 10 years' time. I think, I'm a great petrol head. I'm an engineer. I love, the noise and the sensation of petrol engines. But actually, I'm starting to feel really, really guilty about even owning a petrol car now. So even though I drive a majority of my time in an electric vehicle, I do still get pleasure from driving petrol vehicles. But actually, I feel quite guilty. I feel quite dirty about the fact that that I'm using this precious resource to not achieve anything. But I think that'll be the same for the way we heat our homes. I think we will have to evaluate so much within our life. I mean, just take food consumption. And, we're very fortunate in the UK and the US that we can really get what we want and eat what we want. And, and that's not a good thing at all. But imagine if that wasn't available, what changes would you have to make? Would we move towards a nut-based diet, and what implications does that have for everything else that's going on in society? Because the one thing that I think about and I talk about in the UK is, in the future, we won't have taxi drivers and we won't have lorry drivers and we won't have, I think, teachers are kind of almost redundant. In the UK, we had a period when the parents were teaching remotely, and imagine if we taught remotely everything. What implications would that have? So I think over the next 20 years, we're going to see so much change. Think about how much change has happened in the last 10 years. It's only kind of like 14 years since we had the iPhone and the smartphone. And now, try going a day without your smartphone. It's kind of like, oh my God, cut my hand off. And everything's on there: your banking, your travel, your access to your building. My car will only open if I have my phone on me. So just imagine if we didn't have electricity, if someone cut the cables for a day, how much turmoil there would be. And I think those kind of things are the things that are going to drive change. I think we need to really evaluate what we're doing.
Yeah, I just wanted to re-emphasize the point you kind of really talked about it, with just advocating for meaningful change, especially in terms of sustainability through your wallets, basically, paying for maybe an electric car or exploring, solar panels on houses and things like that. So what other things in MSEs, like personal lives and professional lives, can they do to make meaningful change in terms of saving the environment and just making an impact on our world?
So I think a lot of it's about education. I think there's a lot of people that just don't understand how we need to change or how we can change. I think we make lots and lots of conscious decisions that we're probably not aware of, but we have the leverage, and scientists and engineers are the very best at being able to demonstrate to everybody else how we're going to change. Your accountants and your lawyers, they're not going to change the world. Okay, they're very useful and they're very necessary, but it's engineers, scientists that are going to change the world. And so we need to lead by example, is my thought. And so, I've radically looked at my life and how I do things. Disposable razors are the things that absolutely drive me insane. You go to the store, you buy a disposable razor, you use it, once or twice, and you throw it in the bin, and then it goes to landfill, or I end up seeing it when I go diving. It's really, really wasteful, and we don't need to do it that way. We could use a replaceable steel blade, or, there's lots of things. And so we have to be advocates for how we want the world to be in the future. And we're in a great place to be able to understand that actually, if you turn your dial down on your heating by 2 degrees, if everybody did that, it would change the world. But we don't. And so we've got to kind of be the beacons for being able to drive that change. If you look at electric vehicles, it's generally engineers and technicians and scientists that were the early adopters, because they understood it. They understood what was trying to be achieved. And so, I've no doubt that when we start talking about space travel, it'll be engineers and scientists that are the first ones to join the queue. And so for people that are involved in science, then it's a great place to be at the moment. I think they can really kind of see what the future holds, and they can really be a part in changing that future. And that's not a job, that's a kind of vocation. That's a kind of responsibility. And so I don't look at what I do on a day-to-day basis as a job. I look at it as a service to everybody else. And I think that's the way that we've got to regard it. We're very fortunate that we have the skill set and the experience to be able to make that change.
Yeah, I think that's a less talked about benefit of kind of building your personal brand and just like continuously communicating with others, whether that's like posting on LinkedIn or hosting a podcast or something like that. I think it's just important to be able to bridge those relationships and connect the dots as materials engineers, and just, I guess, be that thought leader in this space too. I think that's a really good point that you mentioned, Neill.
I think the best thing that could happen is we start making politicians material scientists, because we've kind of got the answers. And as I say, I think as soon as the world realizes how important scientists and engineers and technicians are, the greater the benefit to everybody.
Yeah, or at the very least, just having more connection with policymakers, and just kind of having more communication between those two professions or anything like that. I think that's super important too. Yeah,
absolutely agree.
Cool. All right, so we discussed a variety of applications of graphene, from construction to energy to space travel, along with kind of things all related to the space and material science as a whole. So we really appreciate the insights you shared today. And I guess we just love for you to wrap up this episode with your final piece of advice for material science and engineering students and early career professionals who want to make that lasting impact on our society.
That's a really tough gig there to finish off. But my main piece of advice is that we need you guys. So what you're doing is really, really important. You've got to keep going. It's really difficult. There's lots of distractions. There's lots of other things that we could be doing. But actually, we've got a duty, as I said, and that duty is to society and to the planet we live on. And we have the answers to be able to make it happen. So, join me, help us, help everybody. I think it's a great job to be able to do. Yeah,
I love that. Couldn't have said it better myself. But thank you so much for joining us today, Neill. It was a pleasure.
Really appreciate it, guys. Thanks very much for finding the time to talk to me.
As a materials engineer, we can make an impact in nearly every single industry. But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSE Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.